Okay, today we were going to be looking at the factored form of a quadratic equation. And this is factoring is going to be a big part of what we do next as well. Okay, so hopefully working on it in this introductory section is going to help us to build our skills to be successful later on as well. All right, so we are going to look at, we already have worked with quadratic relations in the form y equals ax squared plus bx plus c, and we call that standard form. And so when you have a quadratic in standard form, we can find the y-intercept, which is the c value, the value at the end of the equation, because the y-intercept is when x is equal to 0. So if you sub in x is 0, then the x squared term becomes 0, the bx term becomes 0, and all you're left with is y equals c. And of course, the direction of opening. So if a is positive, we say the parabola opens up, and if a is negative, we say the parabola opens down. Okay, so those are all very, very useful things. But what if we want to do a little bit more? How do we handle that? So we are going to use what's called factored form. And factored form is going to look like y equals a x minus r x minus s. That is the general form of what we call factored form. And that is intense. There is a lot of letters there. And so how do we deal with that? How can we adjust this form of the equation to help us draw a parabola? That's what we're trying to do, or explore a parabola. Maybe you have to state what the vertex is, the axis of symmetry, whatever. Okay, so the reason we're moving away from standard form is because when a quadratic relation is expressed in factored form, we can find, you can see there are 5 dots there. We can do more things. So it still has an a value, so we can do the direction of opening. Okay, so I don't need to write the positive and negative stuff because we already just did it. It can also actually help us, we can figure out what the y-intercept is, and we'll talk about that in one of the examples. But one of the things that the factored form is able to do is it can help us discover what the x-intercepts are. And remember, when you have an x-intercept of a quadratic relation, another way to talk about that is the roots or the zeros. And when we have these zeros or roots or x-intercepts, so these are the x values when y is 0, then what you're going to find is actually the zeros or roots of the x-intercepts, these are the r and s values. And so now when you can discover what the zeros or the roots are without having a parabola, then you can calculate the vertex you can then use the x value of the vertex to write the equation for the axis of symmetry. And once you have the vertex, that will give you what we've called the optimal value, the max or min, which is the y value of the vertex. So much more information can be found. And we'll revisit to the useful step pattern, the 1, 3, 5, and how the factored form can be related to that as well. So the vertex, how do we find the vertex? Well, first what we're going to do is use the R and S values. So when you have a parabola and it crosses the x-axis, then I talked about this yesterday, that the parabola, the distance between the two x-intercepts is a line. And of course, we want to have symmetry, even though my parabola is terrible here. Let me see if I can just fix it. We want to have symmetry, right? So the parabola has to be cut right in half. So when you're cutting something in half, essentially you are finding the midpoint. Okay, so we are going to calculate the x value of the vertex by adding, actually I'll write it, there's not a lot of space here, I'm going to write it as a mathematical equation. So you calculate the x value, you add what r is to what s is, and divide by 2. Okay, and then once you have that value, then we are going to want to know what the y value is of the vertex, and that has to be determined using algebra. But once you have the r and s value, as well as what an x value is, then we're eliminating some of the letters in the equation, and we are able to just plug the values in. And as long as you're using your integers correctly, multiplying a negative times a positive gives you a negative answer, those kinds of things, then this math shouldn't be too bad. Getting to know the calculator you're going to use when you substitute numbers into an equation, keeping them inside brackets, all of these things that you have used, all of these tools to be successful in calculations that you have been using before, we're going to use again. Okay, so you calculate the x value, and then we can sub that in to find y. Okay, so let's use these strategies to help us. And in this question, I actually decided to not start with a graph. So let's look at what happens when you have the equation. Okay, so the first equation looks like this form. The second equation is a little bit sneaky, but this is a special class of quadratic relations, and you know what? It's okay. We can handle it. So I'm going to leave it looking like it does, the y equals -4, and then in brackets x minus 4 squared. So one of the reasons this equation is a little bit better, we talked about in 3.1, the degree of the polynomial. So you can see that equation has the squared term. And so then that means it's a quadratic equation, whereas when you have the factored form, a bracket x minus r bracket x minus s, it does not have a squared term. So the next step, what we're going to do on Monday is double distribution. So we are actually going to multiply the two factored brackets together and get our equation back into standard form. Okay, so that is going to be a big, big, big deal in grade 10, sort of much like you practiced distribution in grade 9, single distribution, quite a bit, I'm sure. Okay, so that's going to be a big deal for grade 10 because moving forward, we have to go back and forth. We have to be able to multiply these two binomials together to make a standard form equation. And then the opposite of that is called factoring. And that is a big deal. And you're going to see how useful the factored form is, as well as how useful the standard form is. Okay, so depending on the situation, you might want one or the other. So when you have the zeros, so if you want to write yourself a little reminder, these are the x-intercepts, or when y equals 0. What happens is many equations, many parabolas will have two zeros. So equation number 1 definitely has two zeros or two x-intercepts because there are two brackets that have an x term. So the issue is the way the general form of the way that we write the general factored form of a parabola, we write x minus r and x minus s. And whenever you have a negative, you have to be careful of the signs. So in the first bracket, it says x minus 4. So it's tempting to write down that the x-intercept is x equals negative 4. But that's not the case. Because if you subbed in negative 4, I'm going to write it up here. If you subbed in that first bracket, negative 4, as r, then that's what you would do, right? We substitute negative numbers with brackets. So what happens is you have to really think of it as the opposite sign, because of course, a negative is going to influence what happens. So if that bothers you, you don't want to have to remember, oh yeah, I have to change the sign. What you can do is figure out, okay, if y is 0 and you're multiplying, any of the brackets can be equal to 0, and that will make y 0. So if I did y equals 2, and then I made this first bracket equal to 0. It doesn't matter what x is in the second bracket. It could be a million. A million plus 2 times 0 is going to be 0. Same thing with the other bracket. If it was 0, then it doesn't matter what x minus 4 is. That 0 multiplied is going to make y equals 0. So what you can do to prove it to yourself algebraically, if you make the brackets equal to 0, both of them, and rearrange, then you can find the x-intercept without having to remember to change the sign. Okay, so if I move that 4 over, or I move that 2 over, in both of those cases, it is going to give me a 0 in the bracket. Okay, so I'm going to do, if x is 4, 4 minus 4 is 0. 2 times 0, no matter what the other x value is, once you're multiplied by 0, you're going to get 0. Same thing is true over here. If I sub in negative 2 plus 2, that is going to give me 0, and the resulting y will be 0. done. When eventually we are going to do many of these questions, so perhaps you will get more used to thinking of it. So let's say you had this one here. Okay, inside the bracket, it says x minus 4. That means the 0 is going to be positive 4. You can write it as a coordinate, as an ordered pair as well. Hopefully, we are working towards being able to quickly think about what a parabola is and draw the resulting shape, okay? So either way will work. I could have done the same thing over here. X minus 4 equals 0. I have to bring the 4 over and change its sign. So I'm going to get positive 4. Okay? So some people will like to think of it using this algebraic method. Some people will just memorize or do enough homework to recognize when you have something inside the brackets, you're going to change its sign. Okay? So now we have the roots. So we are going to use those roots in order to calculate the vertex. So you're going to do we're going to do the x value first. R plus s divided by 2, and then sub x to find y. Okay, so we have for 4 plus negative 2 divided by 2. 4 plus negative 2 is positive 2 over 2, which is 1. And then if you take the equation and wherever you see x, you sub in a 1. Now all we've got is algebra. So again, if you have a good relationship with your calculator, you could plug that right in, or you can do it in steps. So, I'm out of room. So we have 1 minus 4, which is negative 3. 1 plus 2 is positive 3. So that is going positive 3 times negative 3 times positive 2 is negative 18. Okay, so the vertex is 1, negative 18. Sorry, that goes to this one. So the axis of symmetry, we're going to write as an equation, x equals 1. You could even go down to the minimum or maximum value, which of course is the optimal value. It is the y value of the vertex, okay? Get as many marks as you can. So then when we do the x-intercept, again, we are going to sub in a number for x, which is 0, and solve for y. So that is not so bad. Two times negative 4 times positive 2 is negative 16. And if you are if you like to read your textbook as well, it actually writes a formula to calculate the y-intercept as r times s times a. You can do that, but again, you don't have to do that. You're just subbing in where x is 0 like you would have done in grade 9. Okay? But if you're a textbook reader and you want to do that, you can definitely do that too. So now when you look at the direction, or when you're thinking about the direction of opening, we do not have a graph. So we have to use the A value, which is 2, and that's positive. So that means the direction of opening is up. So our value for the max or min is going to be a minimum. So over here, the A value is -4, which is negative. So it's going to be down, which is a maximum. Okay, so again, you can fill stuff in without having to do the harder stuff like the x-intercepts and the vertex before, fill in what you can, okay? So now when you, in the second equation, y equals -4, x minus 4 squared, there is only one x-intercept, which is fine. We looked yesterday that there could be 2, there could be 1, or there could be none. And so here we have one x value, which makes, one x-intercept value, which makes the calculation of the x value of the vertex a little bit more straightforward. So you don't have to add anything. We're just going to divide it by 2, and that gives us 2. And then I'm going to sub it in to find y. But you do have to remember that that is squared. So you have to follow BEDMAS. We're going to do the brackets first. Then we're going to do the exponent. So that's going to be -4 times 4, +4. So -2 squared is +4. And that gives us -16. So again, go down here. Our optimal value is -16. Our axis of symmetry is x equals 2. The vertex is 2, -16. And then when you sub in x equals 0, you just have to be careful about the squaring. So again, -4 squared is +16. 16 times times -4 is -64. So that is why this question, part of the reason this question does not have a graph associated with it. -64 is a serious grid. And we are trying in this introductory unit about quadratics to not have humongous intervals like counting by 5s or counting by 2s yet. So we are sticking with trying to stick with one unit at a time. So -64 is quite large, would make quite a large graph. Okay. All right, so here we are given the equation of a parabola, and we are going to graph the parabola. So there is a bigger grid, -20 and +20. And so when I actually even here, I just noticed I said state the zeros. Okay, so sometimes you'll see the question written this way because, again, there is a shortcut where if you remember that the general equation for a parabola has -r and -s, then you can look at what's inside the bracket and change the sign. So stating the zeros, you could do x equals -2, x equals +6, or you can do the solving and prove it to yourself algebraically that it is a change sign. Okay, you can do that, no problem. But I think what you're going to find, even if you don't believe me right now, is that eventually you will do this so often that changing the sign of the number inside the brackets will become something you just automatically do. Okay? So we're going to calculate the x and y values of the vertex and write it as a coordinate. So the x value, we add the zeros and divide by 2. But having a good relationship with your calculator can allow you to do this as one step. Not that that is a requirement. Okay? So 2 plus 2 is 4. 2 minus 6 is negative 4. So then the y value is negative 16. Okay, it does say to state it as a coordinate. So this time I emphasize that you should write it as an ordered pair. So the equation of the axis of symmetry is the x value. The optimal value is the y value of the vertex. Oops. Okay, and we're going to calculate the y-intercept. Which is negative 8. Okay, so we will graph the parabola. Now, all we have is the vertex, so let's do that first. 2, negative 16. Okay, and we have the x-intercept. That's not really a lot to go on. So remember one thing that we haven't really talked a lot today about yet, which is the step pattern. And when you use the step pattern, the base form is 1, 3, 5. Our a value is positive. But it's weird to think about because nothing is written in front of the brackets. So when nothing's written there, then it's understood to be a 1. So that means that the step pattern is going to be the basic pattern. What happens if I asked you to graph this equation, y equals 2 bracket x minus 4 x plus 2, things would not be as simple, quite so simple. Okay, so yes, we want to use that step pattern, but you do have to be careful. So making sure that there is symmetry is important. So your I don't know how if I can do a line on here, but your parabola should be symmetrical around x equals negative 2. Oh, maybe I can. Oh, look at this. Okay, so you can, drawing in the axis of symmetry is something that you can do. Is this going to be a ruler? Let's see. Okay, so it's going to be symmetrical around the axis of symmetry, but you can also use the step pattern to help you. So let's do this one that does follow the rules, okay? So we'll go over 1 to the right, up 1. I forgot one more thing we can graph. We have these zeros. So negative 2, 0. Oops. And 6, 0. So maybe you feel good. That's a lot of points. Okay, you've got the y-intercept. You've got the zeros. maybe you feel good about drawing that parabola. But if you would like, you could do the step pattern. Over 1, up 1, over 1, up 1, 2, 3, over 1, up 1. Oops, I didn't mean to make that point there. Over 1, up 1, 2, 3, 4, 5. Over 1, up 1, 2, 3, 4, 5, 6, 7. Okay. Maybe because of the y-intercept, you would rather have gone the other way first. Left 1, up 1. Left over 1, up 1, 2, 3. Over 1, up 1, 2, 3, 4, 5. Over 1, up 1. Oops, sorry. Over 1, up 1, 2, 3, 4, 5, 6, 7. Okay, and then you can draw your parabola. Okay, let's go back up here. What happened here? Oh, jeez. See, look. I tried to do mental math and I made a little mistake here. -6 times, actually, you know what? And I skipped steps, so I'm not going to do that to not mess myself up. Okay, so 0 plus 2 is 2. 0 minus 6 is -6. -6 times 2 is -12. Mrs. Todd, what were you thinking? So the the y-intercept, sorry, is -12, which is what I just showed there. So that's why sometimes, first of all, it's okay to make mistakes. But second of all, it's helpful to have the algebra, but also to have the graph. So now our equation is beautifully symmetrical around x equals 2. We have the y-intercept of -12. We have the 2 zeros. We have the -2 and the +6. And we can check our step pattern. But when you do the factored form, until we get farther along, you do have to be careful. Okay, so what I'm going to do, I'm going to switch over to Desmos for 1 second. Am I going to switch? I don't want this to... No, I can't. Okay, so what's going to happen is if we tried to graph something that had a different a value, then the step pattern would be changed. And we did see that in 3.2 yesterday, where one of the graphs went down by 2, down by 6, and down by 10. So it can be tricky. When you do these questions for homework, you'll notice it does not include the step pattern as part of one of the things in the chart that you have to write down. And the reason for that is because when the a value isn't 1, things start to get a little bit different. Okay? So yes, you can use that to kind of check your answer, but you have to be careful today. Okay, so when we write the equation in factored form, how are we going to do that? So now we want to go the other direction. So let's just write it one more time, what factored form looks like. Okay, and so we need some pieces of information. We need to know what R is. We need to know what S is. So we need the zeros. So if you're a textbook reader, The textbook has an example with a graph. So you look at the parabola and say, okay, these are the x intercepts. And then we're going to do a question. So in example 3 and 4, I didn't use a graph because that can be a little bit trickier, a little bit less visual. Okay, so that's what we're going to do. And then, so if we have R and S, that's great, but we still have A. So you can use any point as the X and Y values. Sorry, I guess it's only one, as an X and Y value to solve for A. Okay, and then you can write the equation in y equals a, x minus r, x minus s. So in the past, if we did the line using x minus p plus q, then in the end, your equation was in y equals mx plus b form. If you did it more like you did in grade 9, where you solve for the b value, then you would have to write your equation in y equals mx plus b form. So that is like your final answer. Okay? All right. So here in example 3, we do not have a graph. We do have the zeros, so we can sub those in as the R and S value. Okay? The basic form is a negative. So when you sub in the R value of 2, that's pretty straightforward, but that -6, oops, again, this is where you're going to get a sign change. So when you simplify that, now we're going the other way. So if I gave you this version, y equals a, x minus 2, x plus 6, you would have written the zeros with the opposite sign. -2 inside the bracket means the x-intercept was +2. +6 inside the brackets meant the x-intercept was -6. Okay, so now we're going the other way. Okay, we still have A. We don't know what A is. So that was step 1. Step 2, I'm going to sub in the point given, which is 3, 5, to solve for A. And X is going to be 3, Y is going to be 5. So Y is 5, A we don't know now, X is 3. There are 2 X's in factored form, so we sub in the 3 twice. Okay, so this looks nasty, but we're just going to do the brackets. So 3 minus 2 is 1. 3 plus 6 is 9. Okay, and then now we have the variable on the right-hand side, which is totally fine. Okay, so we're just going to divide by 9 to cancel them out. And then 5 over 9 is A. Is that a nice A value? It is sure not. But we are not asked to graph this parabola, so we're not too concerned about it. But remember, we want our final answer to be the equation. So step number 3, y equals, A value is 5 over 9. The R value is +2. And the S value is -6. So that becomes +6. And we have written the equation for the parabola. Okay? In number 3, we're given the y-intercept, but that's still a point. And then we're given the 2 zeros. Okay, so this time they are not given as ordered pairs. That's okay, we can still deal with it. So we're going to sub them in. This time the first one we're given is the negative. No problem. I'm going to sub that in using brackets like you would have done when you first did substitution or subbing things in grade 9. Okay, so now I'm just going to make this a little neater. I'm going to change it to +2 because that looks a little cluttered. Okay, and since we have the x-intercept given to us, that is the point, that's the only point we're given, so that's the one we're going to use. The problem with being given the x-intercept as the point, or the y-intercept as the point, you do have to remember crossing the x-axis, sorry, I keep saying x, crossing the y-axis or the y-intercept means that that's the y value and the x value is 0. But if you do remember that, then using the point 0 and -16 actually makes the math a little bit easier. Because yes, there's -16 for the y value, but now inside the brackets, x is going to be 0. Okay, which is pretty easy to deal with. 2, -4. 2 times -4 is -8. Divide the 8. A is going to be +2. So now we're starting to get on the track where, okay, maybe we could graph this parabola. An A value of 2 is a lot nicer than 5/9. Okay, and we have our equation in proper form, in factored form. And that is what we were asked for. Okay, this question asks us to do something else to determine the vertex. So we are going to go back to the roots, add them together, divide by 2, -2, +4 is +2 over 2, which 2 divided by 2 is 1. Then if we do the y value, into our equation, okay, so we have 1 plus 1, which is 3, 1 minus 4, which is -3, 2 times 3 is 6, times -3 is -18. So again, I would accept that if you skip the middle step, but you would definitely have to make sure you knew how to use brackets in your calculator, and then we would want to write the vertex as an ordered pair, 1, -18. Okay, so in the homework, there are number 1 and number 5 are asking you to graph, and then the other questions ask you to do some of the algebra. Okay, so give the different types of questions a try, because there is quite a bit of different ways you could be asked these questions. And again, we're going to, hopefully by doing this kind of work, you'll remember what the axis of symmetry is, what the vertex is, etc., so that when we have harder questions, you're able to know at least what those terms mean. Okay? Thank you.